So let's start my presentation. The title is The Body Sensation Effective Visio-Tactile Presentation Methods in Parallel Agent Control. So advances in AI and robotics have significantly expanded the capabilities of autonomous systems. However, these systems still face limitations in context-sensitive decision-making and real-time adaptation in dynamic environments, making human intervention essential. If a single human could control multiple agents in parallel, task efficiency could improve, but it imposes substantial cognitive and sensory motor demands on the operator. So it is crucial to better understand human cognitive characteristics in part. Prior work has demonstrated that distributed embodiment can occur across multiple bodies. For example, Kishore et al. Examined embodiment when switching between bodies, and Miura et al. Investigated distributed embodiment across multiple synchronized avatars. While both studies showed that body ownership and agency can emerge across multiple bodies, distributed embodiment toward independently controlled bodies in different spaces remains unexplored. To achieve effective PARC, the design of visual interfaces that present multiple environments plays a crucial role. Yamamoto et al. Proposed parasites, a method that presents different visual stimuli to each eye. Shuru et al. Proposed overlap, which overlays multiple environments through transparent blending. However, the lack of systematic comparison leaves their cognitive strengths and limitations unclear. Turning to related work on tactile presentation, prior studies have shown that tactile feedback enhances embodiment and performance. For example, McAnally et al. Demonstrated improvements in embodiment and task performance, while St. Aubert et al. Showed that quantifiable tactile stimulation enhanced the sense of walking and body ownership. However, prior work has focused on single-body environments, leaving its role in distributed embodiment unexplored. Based on this background, we propose dual-body sensation as a new theoretical construct of distributed embodiment. DBS refers to a cognitive state in which a single operator simultaneously perceives embodiment and interacts through two independently controlled robots in distinct environments. Building on this concept, the objective of this study is to investigate the cognitive feasibility of DBS in PARC by examining how different combinations of visio-tactile presentation influence its emergence. From this slide, I will explain our experiment. We defined three experimental objectives. First, to compare different visual presentation methods. Second, to investigate the cognitive feasibility of DBS. And third, to examine whether the subjective intensity of DBS is modulated by multisensory visual-tactile presentation. 16 university students participated in the experiment, and to control for potential performance differences due to handedness, only right-handed participants were included. In the experiment, participants controlled avatars placed in two separate virtual environments and performed dual reaching tasks, where they were required to touch targets. I will explain the experimental conditions. This experiment employed a 2x3 within subject design consisting of 2 visual presentation conditions and 3 tactile presentation conditions. For the visual presentation conditions, the first was the independent view condition, in which different virtual environments were presented separately to the left and right eyes. The second was the superimposed view condition. In this condition, we used an overlay method presenting both environments transparently to both eyes. Next, I will explain the tactile presentation conditions. Tactile feedback was delivered as vibro-tactile stimulation to the soles of the participant's feet. The vibration was synchronized with the movement when each avatar's foot contacted the virtual ground. The first condition was the no-tactile condition, which served as a baseline to evaluate the contribution of tactile feedback. The second was bilateral tactile condition, in which the left foot step of avatar L was presented to the participant's left foot, and the right foot step of the R to the participant's right foot. This mapping was designed to align with the independent view condition. Third was the unified tactile condition, in which the left foot step of avatars were presented to the participant's left foot, and the right foot steps to the participant's right foot. This configuration ensured cross-modal consistency with the superimposed view condition. For evaluation metrics, subjective ratings were obtained using a visual analog scale questionnaire, and objective behavior metrics were collected. For the statistical analysis procedure, we checked statistical assumptions first, then applied repeated measures ANOVA or a non-parametric alternative. Next, I will present the results and discussion. We begin with comparison of visual presentation methods. These results show cognitive load and cyber sickness. We conducted a two-way ANOVA, and in both cases, a significant main effect of visual presentation was observed. Both cognitive load and cyber sickness were significantly lower in the superimposed view condition compared to the independent view condition. Next is the blink rate and task performance. Again, we applied a two-way ANOVA, and a significant main effect of visual presentation was observed. Blink rate was significantly higher in the independent view condition, and the total number of target contacts was significantly greater in the superimposed view condition. The higher cognitive load in the independent view condition may be explained by binocular library, as different visual inputs were presented to each eye, requiring attentional switching. Regarding cyber sickness, prior research explains it based on sensory conflict theory, and it has been reported to correlate positively with brain play. Because our task involved locomotion, visual vestibular mismatch likely occurred, and interocular inconsistency in the independent view may have further intensified this conflict. As for task performance, the superimposed view reduced cognitive load and cyber sickness, and preserved depth perception. These factors likely contributed to the improved performance observed in that condition. Together, these findings address our first experimental objective. Next, I will move on to embodiment and dual body sensation. For a sense of body ownership and agency, a significant two-way interaction between visual and tactile presentation was observed. Specifically, under the unified tactile condition, ratings were significantly higher in the superimposed view condition compared to the independent view condition. As for DBS, we applied a two-way ANOVA, and a significant main effect of tactile presentation was observed. Both the bilateral and the unified tactile condition produced significantly higher DBS scores than the no-tactile condition, with the unified tactile condition showing the highest ratings. For body ownership and agency, the superimposed view combined with unified tactile feedback produced the highest ratings, suggesting that visio-tactile integration plays a crucial role in embodiment. In contrast, the independent view increased cognitive load and cyber sickness, which may have disrupted visio-tactile integration. Regarding DBS, the ratings were above the midpoint across all conditions, suggesting that it emerged regardless of presentation method and supporting its cognitive feasibility. Moreover, tactile feedback significantly enhanced its subjective intensity. Together, these findings address our second and third experimental objectives. Finally, I would like to conclude. To support more effective and less effort feedback, this study proposed DBS, a theoretical construct of distributed embodiment. DBS describes a cognitive state in which a single operator simultaneously perceives embodiment and interacts through two independently controlled robots in distinct environments. The objective of this study was to investigate the cognitive feasibility of DBS by examining the sensory conditions that enable its emergence and modulation. The results demonstrated the cognitive feasibility of DBS under dual agent scenarios in PARC, and its strength was significantly enhanced by the introduction of tactile presentation. These investigations lay empirical groundwork for the study of DBS and contribute to the design of future practice systems in which bodily control and awareness can be distributed across remote environments. Thank you very much for your attention.